In this series of videos, we'll be examining in depth the concept of modulation within synthesis. Now, the term modulation gets used a variety of different ways with musicians. If you're talking to a traditional performer or composer, modulation is a harmonic tool. It's a changing of key center to provide an emotional lift or drop within a song. I might have the verse of a song within C major, but then the chorus of the song in F major to provide a dramatic lift for the chorus. Now, modulation is not very common in electronic dance music, so we tend to talk about modulation in synthesis when talking in dance music circles. And that's what we'll be examining here. And modulation within synthesis really is the time dimension of synthesis. It's how a synthesizer sound changes over time. If you hear a patch in a synthesizer that rises in pitch, or descends in pitch, or goes wow, wow, right? The timbre changes. All that is some sort of modulation. And it really is an essential component of synthesis in general. We're going to dive into the specifics of modulation, and we're going to examine envelopes and LFOs in great detail. We're looking here at a block diagram of a typical synthesizer. And a synthesizer really has three main modules. The oscillator, which creates the sound, often a very buzzy, harsh sound. The filter, which removes the portion of that sound that we don't want to hear, often reducing the high end. And an amplifier, which controls the level of that sound over time so we can kind of craft the sound before we hear it. Now, that's the sound path or the signal path through a synthesizer. But there's a second type of signal, control signals. These, in traditional synthesizers, were variations in voltage that controlled specific parameters on those three objects. Very often, we'd want the oscillator pitch to change, which makes sense. Say I had the output of a keyboard. The signal or control output from a keyboard would be connected to the pitch input of an oscillator. So that way, as you play up and down the keyboard, the pitch of the oscillator changes, and it can be played like a keyboard, right? Obviously, we need that if we're to have a usable synthesizer. And that is a type of modulation. It's the signal output of the keyboard or control output of the keyboard connected to the pitch input of an oscillator. We don't hear that control signal directly. We hear the impact of that signal on the oscillator, it going up and down in pitch. Each of these modules has one main thing that is modulated or changed over time. The oscillator pitch, like we just talked about. In the filter, it's the cutoff frequency that's modulated most commonly over time. And in the amplifier, it's the level that's changed over time. And because that's so common, that change over time, we actually have another name for the oscillator in a synthesizer. We can call it a voltage-controlled oscillator, or VCO. And that voltage-controlled does mean that it accepts a control signal to change a parameter. And for an oscillator, the parameter you're most likely changing is pitch. On the filter, we call it a VCF, or voltage-controlled filter. And again, that voltage-controlled means a parameter is changing over time. And in the filter, it's going to be the cutoff frequency. And in the amplifier, we can call it a VCA, or voltage-controlled amplifier. And it means the amplitude is being controlled over time. Now, the example I gave already of key position controlling the pitch of the oscillator is a kind of direct control or direct modulation. It's direct human interaction that's changing that thing over time. But we also like to have some kind of programmatic or algorithmic changes in these parameters. And that's where the final two synth modules come into play, the LFO and the envelope. The LFO provides consistent cyclic variations. Maybe I'd like to imitate kind of a singer's voice, which tends to vary in pitch as one holds a note. To do that, I would need the pitch of the oscillator to change cyclically, back and forth, over time. That's what an LFO is for. LFO stands for low frequency oscillator, and again, it creates slow cyclic variations. Now, we don't hear the output of the LFO directly. Instead, we hear its impact on the oscillator in this instance. So if I wanted to create musical vibrato or variations in pitch over time, I would need an LFO output connected to the pitch of the oscillator that will change that cyclically over time and give us that musical vibrato. Now, anytime you have a modulator, you're really going to be thinking about the time dimension and amplitude of that control signal. So if we look at the diagram of a typical LFO, we're going to see time horizontally and depth vertically, or amplitude vertically. And we can see that the diagram I have here has kind of a sine shape, which really would be appropriate in creating some sort of vibrato sound if we're changing the pitch of the oscillator. We have one other type of modulator, which is our envelope. And while the LFO was a consistent repeating pattern, an envelope is more like a piecewise function. We define a series of points, kind of like a Cartesian coordinate system. We have time horizontally and amplitude vertically, and we can set a series of breakpoints. Every time you hit a key, the envelope interpolates between those breakpoints, creating again, a control signal that can be used to control pitch, cutoff frequency, or volume, or a host of other things depending on what the synthesizer offers. In almost every synthesizer, there is an envelope, or one of these piecewise functions, connected to the amplitude of the amplifier. We tend to call it the amp envelope. Now, a typical envelope in an old synthesizer might have 4 stages: the attack stage, the decay stage, the sustain stage, and the release stage. But we're going to find that contemporary synthesizers can have many more stages than that, and really envelopes have become quite complex in the digital domain. So we've seen primary modulation, which is how one of these things, direct control, an LFO or an envelope, can control one of these main parameters in a synthesizer. But we can also have secondary modulation. I can have additional envelopes that control the depth of the LFO that's controlling the pitch of the oscillator. Maybe the singer's vibrato doesn't enter right away. It starts steady and then the pitch comes in. If I wanted that kind of thing, I would need a rising envelope to control the depth of the LFO, which was controlling the pitch of the oscillator. Again, we wouldn't hear the output of the LFO directly, we would hear the impact on the oscillator's pitch. So, synthesis ends up being this great web of modulation of an envelope controlling an LFO that's controlling the pitch of the oscillator, and then we're hearing the output of that oscillator. And we can have many of these really interesting interconnections, and that's what we're really looking at in these videos. How can we really treat a synthesizer? It's like a Lego toy where we're plugging all these simple objects together in a variety of ways. Now, anytime we connect modulation or we set up modulation, we'll have to configure and think about 4 different things. We'll have to have a modulation source, which would be direct control, LFO, or envelope. We'll have a destination. Our most common destinations are the oscillator pitch, the cutoff frequency of the filter, or the amplitude or volume of the amplifier. We'll also need an amount. Right? We need to know how much the pitch is going to change based on the LFO's output. And we'll need a direction. When the LFO goes up, does the pitch go up? Or when the LFO go up, does the pitch go down? So when we make any of these connections, we can always control the amount and the direction of the modulation. Sometimes it's hardwired into the synth, and sometimes we have very specific control of that.